Hello, AP Statistics. In this video, I am just continuing on to the end of our notes in Unit 2. So I'm just picking up where I left off in the last video. So the next thing we're going to talk about is how to calculate my Lsrl using summary statistics. Well, what does that mean? That means that sometimes you're given information about a set of data rather than the equation or the graph, and by graph I mean the scatter plot. So sometimes you're given other information and you're expected to find the Lsrl. So the other information I'm talking about are your summary statistics. And when I say summary statistics, I mean that from the data you will get the mean for both your response and explanatory variable, and you'll be given the standard deviation for both of them, along with the correlation. If you have these 5 pieces of data, then you can find the slope and the y-intercept, and therefore you have enough information to find your equation. I have an example for this particular type of problem that I'll do in a later video. It's going to be example 6, I believe. So look for that example and you will have a better understanding of how to do these problems. Okay, the final thing I want to talk about, just this idea of correlation and regression wisdom. So we need to talk about a couple of different kinds of points here. So points with high leverage in a regression, they have a much larger or smaller x value than the other points in the data. Okay, what does this mean? Well, when I'm talking about leverage, and I'm talking about a much larger or smaller x value than the other points, here's what I mean. Let's say I've got a scatter plot, and most of my ordered pairs are really tightly clumped together. Well, let's say I've got a point over here. Because that point has a long distance horizontally away from the most of the rest of the points, that's considered high leverage because see, it's got a much larger x than most of the points, okay? Or sorry, a much smaller x, because smaller would be here, larger would be here. Another example of this would be if you had a point way out here. Okay, again, notice that there's a big gap horizontally, meaning this x value is much higher than where most of the other values are clumping together. So that is considered, this is considered, and this is considered, those are considered high leverage points because they are far away horizontally from your the cluster of most of your points. Okay, let's talk about an outlier. An outlier is a point that does not follow the pattern of the data and has a large residual. Okay, an example of this, oh, my pen slipped. Sorry, kids. Okay, an example of a point that would be an outlier. Say I've got some points here. An outlier would be something outside the pattern, so it doesn't follow the pattern and it's got a large residual. So something like this might be an outlier, okay? So notice that it's still in line this way with these x values down here, so it does not have high leverage, okay? But it does have a high residual because there's a lot of space here between it and their other points, but it lies outside of the pattern of the other points. So that would be, this right here would be considered an outlier. Okay, now we need to talk about an influential point. This point, if when you take it away substantially changes the slope, y-intercept, correlation, etc., is considered influential. Now, depending on where your point is, it can be more influential or less influential depending on how it aligns or does not align with the rest of your data. So an example might be something like this. Let's say I've got some data here and I've got a point over here, okay? Well, I want you to notice that it lies outside the outlier It's probably going to have a high residual. Sorry, it lies outside the pattern, so therefore it is an outlier. So it's going to have a high residual because if I have my Lsrl here, that's going to be a big distance. And also it's got space here this way between it and the rest of the points, so it is also high leverage. I want you also to notice that should it be taken out of the data, it will affect the Lsrl. So this point right here, because it's farther to the right than most of the other points, it's outside the pattern of data and has a high residual. It is also going to be influential because my Lsrl is going to be pulled toward that point. So if I take this point out, it is going to change that line because now the line, oh dang it, because now the line has a better chance of getting through more of the points. It fits the rest of the points better. So a point like that is both high leverage and an outlier, and it's influential because it will change the relationship. Okay, so now let's look at a situation where you have this. Okay, so this point right here, it is not considered an outlier because it doesn't have a large residual. It's in line with the rest of the data. It's just kind of far away. So it does have high leverage, and it is an influential point because it is strengthening that relationship. See, it's extending that linear relationship. So this point is going to give this a higher correlation. All right, but if I take it out, it is going to weaken the relationship, so it would change the correlation. So it is considered an influential point, but not an outlier. It is considered high leverage, though, because it's got space between it horizontally and the rest of the points.